Welcome to my channel. So I will solve one more problem on the pushdown automata. So here the problem is obtain a pushdown automata to accept the language w to the power of r, where w is a comma b star. So in the previous video we saw the pushdown automata for the language L is equal to w to the power of r, where so this is an example for the palindrome. Okay, so palindrome. So palindrome is nothing but when you reverse the string, we should get the reverse string is also the same. So here we are performing the reversing of a string depending upon the center point C. But in this problem, they have given the language is L is equal to w to the power of r. So here also this example is also to perform the palindrome, but here they have not given the middle point. Okay, now what is the logic behind this language in order to construct the pushdown automata? So let me take few strings belongs to the language, then we will solve the pushdown automata. Okay, the set of the strings belongs to the language is, suppose if the w is a, then w to the power of r is reverse of that a is a. Means the first three a's are w and the remaining three a's are we have got the w to the power of r by performing the reversing the w. Okay, and the string can also starts with b. Suppose if the w is b, okay, then w to the power of r is the reverse of the w, so b. Okay, so on. So in this example we don't know the center point. Okay, we don't know the center point. Okay, let me recall the logic of the previous language, where the language is equal to w to the power of r. So where we have performed the push operation for w, okay, until we get the center point. After that we have performed the pop operation after the center point, that is w to the power of r. So where you have got the palindrome. Okay, means initially the top of the stack is z0. Okay, keep all the symbols of the w onto the top of the stack, so a, b, like that, until we get the symbol c. Once you got the symbol c, what you have done, we have popped all the elements of the stack until we reach the z0. Okay, so here we have the point the c, where you perform the palindrome operation once you got the point c. But in this language L is equal to w to the power of r is there. See here what we need to do, this language is actually is an example for non-deterministic pushdown automata, and this example is actually used to perform the even palindrome. Okay, here the logic is same as the w to the power of r, but here we need to consider the two cases. Because let me take the string belongs to the language L is equal to a, where the first a is w, next are the w to the power of r, and then here what you have done. So initially the top of a is this z0. Okay, I will push the symbol a onto the top of the stack, that is the first a, and then again I will push one more symbol on the top of the stack, and then here meaning that so after 2 a's, meaning that okay, I got the center point. What I will do after the center point, I should pop it. Okay, when I should pop it, so I have got the 2 a's, but according to the given string what I have taken, I have left out with the 2 more a's. So in this case, okay, for this case of the string, by following this procedure, it's not possible to get the entire string. So for this case what we will do, we will consider the two cases. Okay, so the two cases are, If the input symbol is A and top of the stack is A, what if the input symbol is A and top of the stack is A, so simply I will perform the push operation. And another case, if the input symbol is A and top of the stack is A, I will perform the pop operation. Okay, I need to consider these two cases. Okay, and so this is for push operation and this is for the pop operation, and this push operation is actually performed for non-centered point. Okay, non-centered point. And so the pop operation will perform for the centered point. So after the center, so we use this pop operation in order to identify the center point. After the center point, what we will do, we will perform the pop operation in order to get the palindrome of a given language. Okay, so since we have two transition for the same input symbol, so because of this reason, this language belongs to the non-deterministic push down automata. So let me solve the problem by constructing the PDA. So the push down automata for the given problem is, so the initial state is Q0. Okay, the string can start with A or it can start with a B. Suppose if the string is A, if the input symbol is A and top of the stack is Z0, we push that into the top of the stack. Similarly, the string can start with a B, and if the top of the stack is Z0, we will simply push that into the top of the stack. Next, if the input symbol is A and top of the stack is B, so we have to push that into the top of the stack. Similarly, if the input symbol is B, top of the stack is A, we have to push that into the top of the stack, B, A. Now, if the input symbol is A, top of the stack is A, we have to perform two operations. One operation is push operation, that is AA. So meanwhile, we have to perform the pop operation. If the input symbol is A, top of the stack is also A, we have to perform the pop operation. So just now we saw that case. Because we in this type of language we don't know the center point, that's why if the input symbol is A and top of the stack is A, we have performed the push operation, and if the input symbol is A, top of the stack is A, we have performed the pop operation. Pop operation when we perform is with respect to the center point, and when we perform the push operation means if it is a non-centered point. That's why here in the PDA we have written the two transition. If input symbol is A, top of the stack is A, so we will perform the push operation, and if the input symbol is A, top of the stack is A, we will perform the pop operation. Similarly for the B also, if the input symbol is B, top of the stack is B, we have to push that into the top of the stack. Similarly, if the input symbol is B, top of the stack is B, we have to perform the pop operation for the center point. And then we have moved to the state Q1. So in the Q1, once we got the center point, we know that we have to perform the pop operation for the same symbols. Okay, then only we will get the palindrome. Okay, if the input symbol is A and top of the stack is A, we have to perform the pop operation, and if the input symbol is B, top of the stack is also B, we have to perform the pop operation. Okay, now if the input symbol is epsilon, means we have reached the end of the string. The end of the string, the epsilon, and the top of the stack is equal to Z0, because we have popped all the symbols from the top of the stacks. We have end up with only the Z0. So if the input symbol is epsilon and Z0, we have Z0 will come, and then we have reached the final state. Okay. So this is the push down automata for the language W to the power of R. Okay, and since we have more than one transition for the input symbol A, so this language belongs to non-deterministic push down automata, and here the center point we are decided depending upon the two cases, one with the center point and the non-center point, where the non-center point is for to perform the push operation and the center point is used to perform the pop operation. And this is the equivalent PDA for the language. L is equal to WW to the power of R. Thank you.